And today I want to bring to your attention my presentation, Future of the Rock Massif in the Influence of Zone Tectonic Disturbance in the Gold Deposits of Kyrgyzstan, Kyrgyz Republic. Kyrgyzstan is a small mountain country of Central Asia. It is located along the Great Silk Road and borders with such countries like Kazakhstan, Chinese, Tajikistan, and Uzbekistan. Kyrgyzstan has a small territory where more than 20% of this territory is occupied by mountains, of which 65% are mountain ranges. The mining industry one of the priority sectors of the development of Kyrgyz economy. Kyrgyzstan is rich in minerals, has large reserves of gold, coal, mercury, uranium, zinc, rare earth metals, and the nepheline cyanides, of which the gold mining industry currently occupies a leading place. The gold deposits of Kyrgyzstan are located in zone of tectonic disturbance, major regional faults. The rock of the rock massif are represented by intrusive and effusive rocks subjected to hydrothermal metasomatic changes, mountains terrain, high seismicity, and active tectonic form, especially discrete anisotropic medium with the initial stretched state. And all of this evolution and management of the stability of open pit carriers, underground mining workings, and dumps of the zone of influence of tectonic disturbance is one of the urgent tasks in the development of highland deposits. I want to give a few examples, large gold deposits in Kyrgyzstan, and first of all is a Kumtor deposit, gold deposit. Kumtor is the largest high mountains gold deposit in Central Asia, located in the Tianshan Mountains system at an altitude of more than 4,000 meters above sea level. Kumtor is the second high altitude gold mining enterprises in the world, second only to the Yanacocha gold mine in Peru, and seventh place in the world by gold reserves. The second place in terms of size and content of the reserve in the Juri deposits. The deposit is located in altitude 3,1800 above sea level, but that deposit is just opening, but the mine has already received the first kilograms of gold. In the future, this deposit will be developed in a combined method, open pit mining and underground mining works. Another upland gold deposit is Bozumchak. The absolute marks of the mine are maximum 2,500 above sea level. To date, about 2,500 primary gold deposits have been explored in Kyrgyzstan. This slide shows the largest deposit in the tectonic map. The main rocks of massif in these zones are represented by highly fractured metasomatites. But it is known that the metamorphism of rocks is understood as significant change in the mineralogical composition, structure, and texture, which occurring under the influence of internal endogenous process of the earth crust with the preservation of the solid state of the rock. As a result of metamorphism, igneous and sedimentary rocks change the physical and mechanical properties. The degree of this change depends on the intensity and nature of metamorphism process. It is kept to distinguish several types of metamorphism: dislocation metamorphism, thermal metamorphism, and dynamic thermal metamorphism. For each of them, has the oven rocks are typical, which characteristic structural and textural features and physical mechanical properties. For example, dislocation metamorphism is limited to areas of development of discharge and other tectonic disturbance. Such metamorphism takes place at a slight hydrostatic pressure and rather low temperature. At the same time, the rocks are mainly affected by on-site pressure, as a result of which the former minerals and structures are deformed and crushed. And such rocks are most susceptible to elastic and plastic deformation. In the formation of thermal metamorphism, rocks, the main factor is the temperature, the source of which is magma. Rock of thermal metamorphism are mainly subject to elastic deformation. And the rock of dynamic thermal metamorphism are also subject mainly to elastic deformation. We were engaged in a detailed study of several deposits. For example, I want to show you one deposit Charat. Charat deposit is confined to the zone of three the most important faults. By the nature of these faults are reserve faults. Rock in this deposit formed under the action of dislocation metamorphism, and quality index of rocks by RQD does not exceed 20 and 30%. It shows the course of rocks from the deposit Charat at different depth, and as can be seen in this picture, the rocks are highly fissured and almost no whole pieces. The following example in the Taldıbulak deposit. Taldıbulak, you can say in a tectonic map. Taldıbulak deposit located at the northern for the Kyrgyz Alato and Isikata fault, and quality index of array of rocks in this deposit doesn't exceed 20%. And by category, here the rocks in this deposit very weak. The rocks of the deposit Taldıbulak massif are also shown at different depths, and there is also a really very weak massif here. The next example, this Kurancaylo deposit. The deposit located in the hanging side of the Oktorgoy faults, and the rocks in this deposit quality index by RQD does not also 20%, and the rocks in this massif, in this deposit, also very weak. And here are in this side, you see rocks from the massif on this deposit. Rocks are intensively fractured and ferruginous. And we can meet only rocks very This slide shows an array of the slopes on the surface, and here too one can observe the disturbed array of fractures. Ensuring the stability of sites of lowland and upland carriers, open pit carriers, have significant differences. The stability of the site of upland open pit carriers depends not only on the technological parameters of the open pit carrier, but also on the geomechanical stability of the slope itself, on which mining operation and development. The main factors of the geological environment that can significantly affect the stable condition of the sites of the open pit carrier during the development of the upland field. The stability in the instrumental array and the safety of mining operation are as follows, like the type of rocks and soils, the structure, texture, physico-mechanical and geomechanical properties, tectonic disturbance, parameters of hydrogeological properties and process, endogenous and exogenous process, thermal field, features of geological structures, terrain relief, geodynamic activity, seismicity, and geophysics field. This slide shows a schema of the features of the influence of tectonic faults on the geological environment. First of all, tectonically active zones in the massif and various faults lead to a violation of the stability of the geological environment, to seismic activation and fracture intensity increase, are as a result of which occurs change in the physical and mechanical properties of rocks, activation and of engineering and geological process, activation of natural erosion slope process, and raising groundwater levels and activating weathering. And as a result of which occurs change in the geomechanical environments, reduced pit stability and heaps on the slope. This slide shows core disking. It is known that the nature of core destruction during drilling determines the size and orientation of the main components of the natural stress field and the strange characteristic of rocks. Core disking indicates a high stress state and impact hazard of the rock mass. Such a phenomenon was detected at the Sarıtübe fields, and these rocks Sarıtübe fields, at the depth of 19 meters, and at the Kurancaylo fields deposits at a depth on 172 meters. The main criterion for determining the impact hazard of an array based on core disking is the ratio of the disk width to the core diameters. The thinning the disk, the higher the stress value. Another phenomenon indicates high voltage in the array. This is the brutal destruction of sample into several pieces, 3 or more pieces. Under initial compression, here pictures, first, second, and third, show rock samples from areas affected by tectonic stresses. The strength of this sample is high. They can withstand a fairly large load. But when the storage limit is reached, they break up into many parts. Figure of 4 shows rock samples from the stabilized zone of the mountain range, where there are practically no tectonic stress. Such rocks are usually destroyed only 2 parts and no more. We observed how the strange properties of rock change with depth, and as can be seen from the graphs, with the depth of the strange properties change very sharply and unevenly. The red line is a compressive strange, and the green line and blue line is a tensile strange. A distinctive feature of the rock of deposits in the zone of tectonic discontinuities is that the value of stretch characteristics are scattered over the depth on the well, and it is not possible to establish a pattern of change in the strange characteristic of rock over depth of the wall. The last graph is based on the result of strange properties of the rock in Shantou deposit, like these samples of rock. As can be seen from this graph, there is a large variation in the volume of strange properties over the depth of the well. There have minimum values and maximum values in megapascals. Our laboratory has done a great deal of research on the properties of rock in deposits with tectonic faults, and based on this analysis of the obtained result of the properties of rock of various genesis and many years of research, we have compiled a table of the values tectonic disturbance. This slide show the average values of the physics and mechanical properties of rocks divided into types of metamorphism. And this table show the only main properties necessary for calculating the stability of the sides and slopes of the open pit career. This slide shows the main rocks of an array of gold deposits and indicated which types of metamorphism are. According to these tables, in deposits of Kyrgyzstan and deposits with tectonic disturbance of rock of this massive, they are treated of dislocation metamorphism. Although the rocks have all types metamorphism, as shown in this table. The study of the physical and mechanical properties of rocks in the zone of influence of tectonic disturbances has established the following results. The rocks in this zone has low porosity, low water absorption. The strength of rock under compression is much greater than the tensile strength. The rocks are fragile. The stretch characteristic of the rocks after the full saturation decreases to 13%. At the same time, the angle of internal friction of rocks practically does not change. The study of the physical mechanical properties of the main factors is assessing the stability of the size of open pit carriers, the properties of the massive and the degree of its disturbance, which is manifested of fracturing and blockiness. A characteristic feature of the rock massif subject to tectonic disturbance in the block structure. The crack intersect and divide the rock mass into structural blocks that have different shapes and size and are called detachment, and the volume of the elementary block is called one structural block. In this slide, you can see a block array of the slope of another gold deposit named Tahtazan. A block array consists of separate structural blocks, each of which has its load bearing capacity. If one block fall out, it can lead to violation of the entire system. That is the collapse of a separate slopes and sometimes even several slopes together. The blocks are interconnected by various cementing filler or aggregates, and sometimes without fillers, just cracks. Here is a picture of the blockness rock massif of the site of open pit carriers during the opening of the Makmal deposit. And this picture, we can see a separate structural block. To study the mechanism of destruction of the instrumental array of a block structure in the laboratory, a method was developed for conduction studies of the resistance of a separate block to separation, and a simple model of a block array was also created, where is a single movable block considered at the main block under condition of volumetric compression. The main part of structure is a horizontal fixed wooden frame. This is a vertical support wall. A drum of the cable, and a device for applying the load. Also, to secure the 9 blocks of rocks built vertically, a retaining wall of plexiglass is made, but along the vertical edges. In the middle of the wall, a hole is made with a size larger than 1 block at the place where the movable block is located, so that the movable block can freely break away or come off. When we're studying interblock cracks on slopes and on cores, the following types of fillers were identified. There are empty cracks without a filler, cracks with a solid filler, and identified which firmly cement the blocks with each other and provided greater load-bearing capacity of the array and the stability of the slopes as a wall for a long time, until the weathering process weakens them. Weak clay fillers were also found, which when they give a weak connection between another blocks, and when wet, practically lose their adhesion and present a greater probability of disruption in open pit carriers. Based on this laboratory testing experiment, sand clay fillers were taken in different ration ratios as shown in this table. 100% clay, 100% sand, and another ratio. The internal friction angle and the coupling were determined in advance for each type of filler. The filler was applied only around the movable block, which should break away, come off. To begin with, experiment was carried out without a filler, just only blocks. Then the side of the movable block were moistened with the water fillers, and then, as in the table, the prepared mixture was applied to a block with a thickness maximum 3 millimeters. Next, the sample was loaded at 100 grams every 1 minute until the block was detached, and so many times for statistic for each kind of placeholder. The humidity of the fillers ratio is 12%. The aim of this simple laboratory experiment was to establish the dependence on the block separation resistant on the type of filler. Based on the data obtained, simple graphs were constructed. The first in the depends of the blocks resistant to separation from various of different fillers, and the graphs show this graph showed that the blocks resistant to separation depends on the type of fillers. With the greatest resistant to separation depends on the type of filler resistant being provided by the filler, where the ratio in 50% of sand and 50% clay. And graph on the depend of the blocks resistant to separate from the filler coupling is also constructed. The large cohesion or adhesion was in the filler with a radio also radio with 50-50, and the tear resistant was also obtained. The block tear resistant depends on the adhesion of the crack filler and is practically dependent on its internal friction angle. Thus, when studying the blockness of rock mass, it is established that the gold deposits are located in zone of tectonical disturbance of various genesis, and the properties of rock are characterized by almost all types of metamorphism. It has been established that rocks in the zone of shear metamorphism have high values of compressive stress and low values when stretched, which is typical of fragile rocks. The properties of rocks in the zone of thermal metamorphism substantially depend on humidity. The gold deposits of Kyrgyzstan are associated with this condition tectonic disturbance in the massif. Up to 5 systems of cracks of different orientation are clearly expressed, which determines the block structure of the rock mass. And substantiated by that use the indicator of quality of the rock mass of field for the assessment for the marginal parameters of open pit carriers to ensure long-term sustainability. When, developing open pit mineral deposits in rock massif in areas affected by tectonic disturbance, it is recommended to do the following: maneuvering of mining operation, direction and speed of movement of the mining front, special guiding of ledge for forced collapse of unstable areas. The purpose of all our research was to study the future of the properties of tectonically disturbed rocks of the massif and apply the result obtained in calculating the stability of slopes of open pit carriers as assigning stable parameters, and also used the choosing a place for rock waste and calculation of this sustainability. And this slide shows one example, the design section of Kuranjaylo deposit, and indicated the safe contour, the future open pit mining calculated by us. I have finished. Thank you for your attention.
Thank you very much, Dr. Gulzat. It was a very nice presentation and very nice to understand the field study, very in-depth field study on rock massive and their properties and what we can do to enhance stability of open pit mining. So now I welcome audience for any question and answers and discussion. Yeah, Professor Askar.
So thank you, Dr. Ankit, for your giving opportunity for giving questions. So thank you for Dr. Gulzat for excellent lecture, especially very interesting geotechnical activity we inspect in Kyrgyz. Very beautiful country, And I want to say you questions about slides of strengths of compression strength slide and tension stress, tensile stress. Some slide I can show.
This slide?
Okay, this one, 21, yes. So you say first compressive, right?
Compressive stage, yes. The red line.
Да. But how you think compression strength bigger or tensile strength bigger?
Tensile strength bigger.
Same compression.
Yes.
Why?
Because all of rocks can. Можно я объясню вам на русском?
Да.
Сейчас просто не смогу ответить.
Лучше на английском. English.
Я сейчас, наверное, не смогу. Сейчас, погодите тогда.
Okay, but anyway, you thinking is tensile strength is more bigger than compression, right?
I just want to say that more of rocks, maybe all of rocks, сейчас. I always using the translator.
Because in conclusion you have another point. In conclusion you say you said compression strength bigger than tensile. In the conclusion you said.
Because they more of rocks can withstand a large compression load, but the rocks.
Okay. Anyway, for me, important.
But they cannot withstand of tension because the rocks are very fragile. Хрупкие, very fragile.
If is not so good connection, so tension, tension is maybe soft, less than compression.
Compression more than tensile. Oi.
But you graphs,
you
graphs is
А,
You
я
say,
неправильно сделала. Сейчас
maybe it is some mistake. Graphs. These
Ah.
graphs. Maybe some mistake, right?
Yes, yes, yes.
I think it should
Compressive.
be, yeah, it should be
Compressive.
reversed.
Tensile
Maybe
strange
this
more than
compressive.
compressive stage.
Да,
Yes,
maybe
yes,
this
yes.
is
Thank
green
you.
column,
Yes.
green column
It's my
maybe
mistake.
compressive.
Mhm.
Red column maybe tensile, right?
Mhm.
Okay. Thank you very
the-
much.
The red line
Finally,
is compressive, is a tensile strange,
yes,
and
yes,
only
this is the red
green
is
line is
tensile,
compressive stage.
green is
Yes.
compressive. Yes, very good,
Mhm.
very good. Thank you. Nice presentation. Thanks.
Thank you for your question.
Professor Pulo? It's a
No, no, I like this presentation. It is very interesting. No, of course, most of information that is bringing here, I know about this, and for me, it's okay. No questions.
okay. Yeah, thanks.
I'm glad.
Yeah, Dr. Gulzat, may I ask one question? Hello, Dr. Gulzat. I mean, I have
Yes.
one point I want to discuss.
Yes, I'm hearing.
I mean, this sampling of rocks, you have done it from the field, right? You sample
One more
this.
time.
Yeah, I mean, how the sampling of the rocks were done, because I think that it could be very destructive, the sampling of rocks. So when you especially do the laboratory test, I mean, can you look at the laboratory test? In the laboratory test, those rocks which you used, were they sampled from the field, or you modify it first in particular shape and then you used it? Because I see it was in kind of blocks in the bblaboratory test. Yeah. The rocks here are used from the field?
Yes, yes.
Okay.
Each of blocks was a rock blocks.
Okay, and it was cut
And
also.
I can,
yeah.
And I can show it by my report. I have another flash card.
It's okay. It's okay.
Each of them, each of rock samples was of rock samples. Just
so,
on the block of number 5, which is movable. Also, all of 9 blocks was similar.
Okay.
I just that blue blocks
is movable.
That yes,
can move.
That is movable blocks.
Okay, so the I also want to understand the friction between block 5 and like other blocks like block 4 or yeah. So here you said the humidity was at 12%. So it is a water content, right? The water content you're talking.
Yes, water content.
Okay.
We have a methodical instruction how we can give humidity for the radio mixture for this mixer fillers.
Okay, so there's a standard procedure. Yeah.
But the sand was not absolutely clearly sand. And clay just not absolutely clearly clay too, because its experiment was like testing. They started.
Yes, understood. So it's more.
We are studying. We are research of Blockness Massif only 2 years.
Okay.
It was a starting experiment.
It's good. Yeah, thanks. So any other participants would like to discuss? Okay.
I have one question to organize committee.
Yes.
Will be this presentation available for us?
Yes, actually, we will be, uploading the links of this seminar. Also on the YouTube. But we have to get consent from the speaker. If the speaker allows, we will upload it on YouTube, and we can also share with you the recorded seminar along with PowerPoint after getting consent from the speaker. Yeah.
Okay, thank you.
Yeah.
Because we want to show this presentation to our colleagues, especially for young colleagues.
Yes.
Demonstrate.
We plan. We have uploaded last presentation already on YouTube, and this presentation, I think Professor Dr. Gulzat will, if allow, we will upload on YouTube definitely.
Okay.
Yeah.
Thank you.
I agree.
Thank you.
Thanks, Dr. Gulzat. Yeah. Okay. So maybe I think time is almost there, very close. So with this, I would like to conclude the session. Keynote speech by Dr. Gulzat, a very wonderful lecture on rock massive and how we can minimize failure of open pit mining and enhance the stability.
Thanks a lot.
Yeah, thanks, Dr. Gulzat, for your time. And just for information for participants, tomorrow we will again have a lecture. I think it will be from Uzbekistan. So this lecture will be more on, so if you can look at the screen, it will be more towards soil interaction with the biochar. It's also organic material, and it has more implications towards agriculture and environment. So it will be a different theme altogether from what we have seen today, but it's again very important for soil mechanics point of view of soil scientists to also look into agriculture and environment, and especially Uzbekistan is a neighboring country of Kyrgyzstan, is also a very beautiful country. So Dr. Dilfuza, she will be speaking tomorrow at 2 p.m. China time. It will be 2 p.m. China time, means it will be around 12 o'clock in Kazakhstan time or Kyrgyzstan time, and will be around 11:30 a.m. Indian time. So Indian time will be 11:30 a.m. So please.
In Tajikistan, 11.
Yeah, in Tajikistan, yeah, in Tajikistan it's 11. I think in Uzbekistan also it's 11, if I'm not wrong. Yeah. So tomorrow we again we like to see you all to listen to again wonderful lecture from Dr. Dilfuza. Yeah. So with this, I would like to conclude this session. Have a good day. Yeah, all of you.
Thank you.
Thanks. Bye.
Bye.
Hi, thank you.
Thank you to all.
Thank you very much. Bye.
Bye. See you tomorrow. Bye.
Yes.
Yeah, see you tomorrow. Many thanks for your participation in this event.
Okay.